Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the SAT. We have been solving math questions and grammar problems out of this book here, grammar questions out of this book here, the official SAT study guide, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 414. Today is our lesson number 21. Now listen carefully please. As I explained yesterday when we did question number 1 and 2 in this section, that this section has 18 questions. And as I always told you, SAT being a standardized exam has all the questions arranged in the order of difficulty into thirds. All the questions are arranged in thirds. The first third are easy, the next third are medium, the last third are hard. Since there are 18 questions in this section, as you look at the top of the page there, it tells you right there are 18 questions. It's logical to assume that the first 6 are easy, the next 6 are medium, the last 6 are hard. But that is not the case here. The reason why that is not the case in this particular section is because there are two types of questions. That would have been true if all 18 were of the same type. Here, in this particular section, the first 8 questions are multiple choice questions. And then starting from 9, we have a different type of questions. We have what is known as the gradient questions, where you have to grade in your own answers. From 9 through 18, these 10 are gradient questions. And therefore, we have two difficulty scales. One goes from 1 through 8. 1, 2, 3 are easy, then the medium, then the hard, and then starting from 9, we start again with the easy one. In other words, number 8 is a pure help. Number 9 is a piece of cake. You got it? We are on number 3 right now. Number 3 is a sort of easy, sort of medium, we'll see. It's not that difficult. It's easy and medium. It says, a restaurant has 19 tables that can sit a total of 84 people. Alright. Some of the tables sit 4 people and the others sit 5 people. The question simply is, how many tables sit 5 people? It's very easy, very straightforward. We know that they have 19 tables. What we're going to do is we're going to assume that every one of those 19 tables sits 4 people. Let's assume that every one of those 19 tables sits 4 people. Let's see what happens. 9 4s is 36. 34 plus 76. Now, had that been the case where in the entire restaurant all the tables sat 4 people each, we would have had, it's a hypothetical statement, we would have had a capacity of 84 people. But we are told that in reality the restaurant can sit 76 people rather. But we are told that the restaurant can sit 84 people. If you were to subtract 76 from 84, we get 8. This 8 implies that there must be 8 tables where 5 can sit. This is where the 8 extra people are. So we started out by assuming that every one of the 19 tables sits 4 people each. One more time, and had that been the case, we would have had the capacity of 76 people. But because we know that this restaurant has a capacity of 84 people, that implies that there must be 8 tables in this restaurant where 5 people sit. Where 5 people can sit, because we are told that the restaurant has either this table or that table. That's it. A restaurant has 19 tables that can sit a total of 84 people. Some of the tables can sit 4 people and the others 5 people. There are no tables where only 3 people can sit or where 6 people can sit. It only has 2 types of tables. 4 people and 5 people. So there must be 8 of those tables where 5 people can sit. That's all. That's it. We are done. The answer is E. Let's do the next one. Let's do the next one. It says if A equals 4, which of the following is equivalent to m squared plus a to the m, a times m plus a. Now before we worry about the fact that a equals 4, let's first simplify this damn thing, shall we? Let's simplify it. So do you see anything here that we can take out common? Do you see anything here? I see A over here in this term, the last term. I see A in the first term. I see A in the second term. We can take out A common. Let's take out A common. That's how you say it. If we take out A as a common factor, in the first term, we are left with m squared. Because A times m squared will give us A m squared. Plus, if we take out A common from the second term, we are left with m. Because you see, A times m will give us am. And finally, if we take out A, what are we left here? A 0? No, not 0. Because A times 0 would be 0. We're not left with 0, we're not left with nothing. We are left with 1. Because 1 times A will give us our 1. Will give us our A. That's it. Now they tell us that A equals 4. So you just replace A with 4. A equals 4. So we replace it with 4. Because that's what we are told. We are told that A equals 4. That's our answer. That's it. Is there anything here that looks like that? 4 times m squared plus m plus 1. The answer is D. The answer is D. That's it. We're done. That's all. The two questions that we just did, number 3 and number 4, they were level 2 questions. They were level 2 questions. College Board does not speak of the difficulty of a given question in terms of easy, medium and hard like I do. I speak loosely. College Board likes to categorize every question on a scale of difficulty from 1 to 5. They speak of level 1 and level 2 and so forth. These were level 2 questions. The next one that we'll do tomorrow is a level 3 questions, which is a medium question. I'll see you tomorrow, okay? Bye now.